Thanks for coming after lunch. I know that this is a sleepy time, especially on day 2, and we are talking about data. But I'll try to keep it lively and have some good examples, hopefully. So I'm Julia Wester. I am going to talk to you about data, the good, the bad, and the ugly, or rather the just plain unforecastable. And these will be true stories from my own experience, and we'll talk about that in a little bit. So the first thing to think about is the hard truth that we all come to discover sooner or later is that all data are not created equal. I scoured the internet for 5 whole minutes trying to figure out who said that, and I could not figure out who it was. Wasn't me, but it is true, right? So I don't know how many of you have ever gotten a shiny new toy to analyze your data to forecast with, or like us, we built one, and then you get so excited and you throw your data in there, and you can't wait for that awesome forecast, only to be significantly disappointed by what comes out the other end. It's either not a forecast, dates you just really hate, or just nothing you can show to anyone. And so that's sort of the impetus of what this talk is about. But before we go into the details, let me share just a little bit about myself. Don't worry, we're not going to go into this. These are just random facts. You can come talk to me about any one of these, plus maybe more. But the important thing is that I'm taking thoughts and prayers as a mom of 3 teens. And also, I work at 55 degrees. So this talk is not about products or anything, but in building products like Actionable Agile Analytics or Portfolio Forecaster, the other ones that we have, we use it and we experience all the same things customers deal with their data, or companies like you deal with your data, and we work with a lot of other people trying to use their data, and we hear the frustrations that come out when you, especially for the first time, try to put that in a tool and get all the goodies out and then just get frustrated. So before we talk about those different scenarios, I want to get aligned on what kind of data that we're talking about. So the forecasting part was a bit of a clue, but we are going to talk about data that gets generated as work moves through its life cycle. So generally, this might be data that gets generated when you move Jira issues through a workflow statuses, or Azure items through their statuses, or anything like that. Or even if you have manual cards and you're moving them across your board, you might capture a little information about when it starts, when it goes through parts of its life cycle, and when it finishes. So that's the kind of general data that I'm talking about and that we'll be referring to. And here are some of, these are 4 flow metrics. If you want to learn more about those, you can talk to us, but you can also talk to Pro Kanban downstairs because they've got great information on this. But these 4 flow metrics, cycle time, throughput, work item age, and work in progress, or WIP, are the 4 basic pieces of information that you need to know to improve your flow, help become more predictable than you are right now, and to do some forecasting. So you need very little data to do some really awesome stuff. We're going to go through 3 different scenarios today to talk about the good, bad, and ugly of data in each of those kinds. The first one's going to be forecasting single items with some cycle time data. The next is going to be forecasting sort of fixed date, fixed scope stuff with throughput and cool Monty Carlo simulations. Someone said that today, and that's going to stick with me. So I'm going to try to use that as often as possible. And then we're going to look at, what if I have multiple fixed date or fixed scope things going on at one time, and I need to get sort of a portfolio forecast for all of those things. And so we're going to talk about a few things that can trip you up in each one of those types of forecasting, and what you might be able to do about it. Okay, so again, this is based on some true stories, but it's blended from mine, from other people's, and whatnot. So to start, forecasting single items on a cycle time scatter plot. So just some level setting here to make sure everyone's on the same page. Cycle time, the definition of that is the elapsed time between when something passes a start point to when it passes a finish point. You can decide what that is, but the total elapsed time between point A and point B. And when we plot those individual dots, which is like a thing that gets finished, one or more things is a dot on this chart. When we start plotting those in aggregate, we can do some really cool things. Like we can see, hey, 85% of the things that we finished finished by 16 days or less. So we're able to do some sort of service level expectations or any other kinds of forecasting out you need to do to tell people when will a piece of work be done, a single piece of work. You don't need fancy simulations. You just need to look at your data in the aggregate, the simplest kind of data that you can, and give that answer. And so a lot of times, people will come in to look at their data for the first time, and they'll say, oh my God, 85% of our work can take up to 120 days or less. Like, that just doesn't feel right or whatever, right? So let's look at a few things that can help make sure your data is hygienic. A few data hygiene things that not only will help with this kind of forecasting, but then also will carry on to all of the other types that we're going to be discussing. These will be important throughout. So there's 3 questions I want you to learn to ask yourself. And the first one is just the most basic. Is your data accurate? Like this cute little pawn is looking in the mirror and sees a king, right? That's not super accurate, or queen, yeah, I'm not sure which one that is. But what you want to think about is, are people updating the systems, the source data systems? So Jira, say you have Jira cards on a board. Are people keeping those up to date as the work is actually moving through? Is it in real time? Or do you have situations like at the end of the week, everyone moves their card? Or sometimes people ask, do the Scrum Masters go move my cards for me? Like, how does that work? And so if you think about data as the voice of your process, and we're looking at all of this data that gets generated, and you learn how to read it, you are able to then look at some data and understand a lot about how a team actually works. Once you start to learn patterns and things like that, and you can ask questions and learn a lot about a process by asking questions about the data. So this data is the voice of your process. It's telling you what you've been capable of so far. But if we think of that, what comes out as a story it's trying to tell, we need to make sure it's a nonfiction story, right? We can't use fiction to forecast real-life futures. So if you have data that's not actually being updated, people aren't keeping their systems up to date, they're not moving their cards, all of that, then the data that comes out is not going to help you get good information about what you can do in the future. Right. So that's the first maybe disappointment of this talk, is that it takes work to get data that gives you good forecasting, good information about your process. I don't think that there's a way to really get around that. Sort of garbage in, garbage out. The second thing is the data representative. So when I'm using the data and I gathered data about something, and then I don't really know what's inside of it. I'm just going to use it to forecast this thing I need to forecast. If I don't understand what's in that data, like what kinds of work was in that data, I'm going to go over some specific examples, but if I don't know that I'm comparing apples to apples, if I have wildly different types of data in there, and then I try to use that data to forecast a very niche kind of thing, then I'm going to give myself some incorrect answers. But I might not know that, and then I might use that as truth, and that's when you sort of, people say, well, your forecast was wrong, or, things like that. So the second question is the data representative? And then the final question, if you hear people talk about probabilistic forecasting, who's heard of probabilistic forecasting? Okay, a lot of you. For everyone else, in 2 seconds, you're going to know what it is too. It's any forecast that gives you an understanding of the probability or the likelihood of an outcome occurring. So 85% chance of, right? So let's think about the weather report. There's an 85% chance of rain between 1 and 2 p.m. So the 85% chance is a probability, and then the rain from 1 to 2 p.m. is a range. Because I think everyone here sort of embraced this agile concept that there's more than one possible outcome that we could have. And we cannot know enough at the start to know which single outcome is going to happen. So then we've embraced the possibility of uncertainty. There are multiple things that could happen. So when we're forecasting, our data becomes a critical tool to be able to examine it and see what all those possible outcomes could be. That's what our data lets us do. So if we are looking at a probabilistic forecast and we want to be able to say things like 85% of the time you can get a piece of work done in 10 days or less, then the third thing that we have to know about that, and there's probably a lot more, but these are the big three, is that that data was generated in a situation that's going to be roughly similar to the situation I'm forecasting for. And so what I mean by that is that if I generated some data over the last 6 months, and then I lay off half my team, right, for some reason, then my conditions are no longer stable, right? I don't have data yet from my new situation. I can maybe use that past data and maybe do some scenario planning with it, maybe cut it in half or something like that. But it's not generated under stable conditions. So the good thing there, and we'll talk about that, is once you get that new condition, it's okay, but you just do a little bit of work and generate some more data, and then you've got your new data and you can go forward. And we'll talk a little bit later about how much data you need. It's not a lot. So those are the three questions. Is it accurate? Is it representative? And was it generated under stable conditions? So let's talk about, I said we were going to talk about the good, the bad, the unforecastable. I'm going to start with the unforecastable. And I think it's pretty obvious to say that if your data is not accurate, you can create as many forecasts as you want, and the forecast is going to be useless because it's not based on your reality. So you can technically generate a forecast, but it's not relevant to you whatsoever. Okay. And it doesn't matter if that data is representative or if it was generated under stable conditions. If it's not real, your forecast isn't real either. And I think that you might start realizing now what Pavel said in his opening keynote, I'm going to paraphrase it, is that, it's not necessarily about learning a whole bunch of new things that you need to know to be successful. Sometimes it's about better using the information that we already have. So as we start walking through this and you're thinking, on retrospect, that's pretty darn obvious, right? A lot of us know all of this stuff and we're still not doing it, right? So what we want to do is start thinking of this stuff again so that you can go back and say, here's more reasons why it's important for us to do the things that we need to do. If we want to gain these capabilities to create forecasts, then here's the work that we need to put in. Okay, now the bad is you can have accurate data, but if it's not representative, then you can start making a forecast, but it won't be so great. And I'm going to show you an example from a board in my team that I pulled yesterday, because it actually took us a little bit to figure out, oh yeah, we need to go do this filtering. So I know that some of you are probably caught in this trap too. So let's say I pull in a JIRA board for one of my product teams. And I use just all of the data. I haven't done any filtering or anything. And so I get sort of these kinds of forecasts. I can look at my data, and this is sort of the summary. I can say that, hey, almost all of my work will take no more than 55 days, 20 days, 8 days, 2 days at different probabilities. And I'm thinking, okay, not so bad, right? And then I realized, oh, there's some stuff in my data that might be skewing this. So the first thing is my data set has a bunch of different scales of work types. I've got parent cards, children cards, niece cards, nephew cards, all kinds of stuff, right? And so I need to think a little bit about what I'm trying to forecast, right? If I throw massive things in and I'm trying to forecast my smaller things, it's going to skew it. And there's some other nuances I can put in too, but you roughly want to think about, again, that apples to apples. Is it representative? I want to go filter down to the kinds of things I'm trying to forecast, and use that same kind of data. Now, the biggest thing, I think, the biggest thing that we keep forgetting is that in a lot of systems, and we use Jira primarily, when you close an item, you can have many different reasons for closing it. You can have done it, which is by far the one that we do the most. Empty are ones that aren't finished yet or for some reason didn't have a done attached to it. But then there's also things like we close this because it's a duplicate, or we decided not to do it, or I created a request in another place because that's some other person's work. And if I think about that, when those items close, they're not going to take the normal amount of time to figure out that that was a duplicate. They're going to go through in like one day, right? A lot of these that I'm filtering out are super fast. So here's what happens when I filter those things out, just those two filters on our actual board. It shot my 85% up by almost double, right? I'm not that fast at math. But, and the others, 70%, maybe 150%, and yeah, 50, forget about it. So it is really important that you know what's in your data. You can't just throw it in and magic up a forecast and say, this is what's gonna happen with a 90% probability, right? We still have the responsibility of understanding what's in our data, right? So if our data's telling the story, we have to read through it, we have to understand what the chapters are telling us, and we have to interpret this well to others. Okay. Now, obviously, the good is when it's accurate, when you have representative data, and when you have those stable conditions. And ideally, you can get to the point where that first picture, where it had much better forecasts, I can get to that by improving my data, even when I filter down to all these things, and that's the goal. So when you first get a forecast, you may not be happy with that. Like, I'm not super happy with that forecast that we just saw. But now I've got work to do to make that better and improve it. But at least I know I'm looking at the truth, and I'm not being fooled by unfiltered data. I do want to be responsible and say that filtering sometimes can be a little bit of an art and not just a science. There is a risk that you try to get too specific and filter out things that might actually happen again. So just, some of this is science, like the resolutions and stuff are quite easy. That's obvious. Some things are, a bit more nuanced. But you can always ask friends online or us or whatever for assistance. Okay, now even when it looks good though, there's something you need to look out for to make sure it's going to stay good. And this is something, if you notice, I have a note here that this is from a screenshot from the online Twig game. Because when I've taught classes and we use the Twig game, I found that I keep seeing a certain scenario over and over. And that's when they've got to the cycle time to looking awesome, right? Great. But lurking in the shadows is all this crap they put to the side so that those things could finish quickly. But you can't sustain that forever. Eventually, these things are going to close, right? They're going to be dots on that cycle time scatter plot, and it's going to go back from having low, 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 low to all spread out again, right? So you get to that good spot, but make sure you can sustain it. And by the way, the flow metric that I'm looking at here is work item age. So whether or not you have a chart like this, or you're doing stuff manually, the thing that you want to look at, if you think you have good cycle times and you want to make sure you can sustain it, make sure that the work item age you don't let items age unnecessarily, right? Things take as long as they take. But we make a lot of choices every day that make things take much longer than they really needed to. So, and the definition of work item age is very similar to cycle time. It's also an elapsed time, but it's from when an item passes the start point to right now. So either an item has an age or a cycle time. Okay, second scenario here. Forecasting items with throughputs in Monte Carlo. So this is our fixed date, fixed scope situation. And so let's say we're trying to plan for a sprint, right? And we're trying to figure out how many items we can finish in a sprint. And we want to use our data. We want to have an understanding of the likelihood of finishing a certain amount of items. So what we look at is the throughput. So that's the number of items that finish in a given unit of time. And we like to look at that on a daily basis, a day-by-day basis. Okay, and sometimes, if you haven't yet thought about flow within those boxes that you're planning for, you'll get situations like this, where you have really dry spells, and then a bunch of stuff gets delivered. So it's like the burn-down cliff on a sprint, where everything's going, and then it finishes all at the end, right? So what you're going to get from this is some pretty inaccurate forecasts if you're using daily throughput, which there's a reason that you should. We'll talk about that in a second. But the way simulations like these work is they sample your historical data to see, run days and days of you working to see what you're going to finish. Well, what's it going to sample most here? Zeros, right? So you're going to get more than 0 finished. This isn't a usable forecast. So you might think, well, why not roll up the data so I have fewer zeros? So let's start looking at weeks or sprints. And that's absolutely a good question. You can do that. But you need 10-ish data points to have statistically relevant sample. So that means instead of being able to use 10 days worth of data and being really responsive and reactive, you start having to have 10 weeks or 10 sprints worth of data. That can be a long time, right? So I think it's better to focus on improving the flow throughout your day-to-day process and start delivering more constantly within those kinds of time boxes than trying to figure out how to make a better mousetrap or roll things up. Because if you're trying to get fast feedback, using longer time boxes is not going to help. Okay. So this is obviously the good, that more constant kind of flow through your sprints or anything else. So I think the takeaway from this is, consistent delivery of even smaller amounts of stuff from a forecasting and predictability perspective beats high spikes every single time. Now, finally, I want to talk to you about a scenario that we had. And so we built this thing called Portfolio Forecaster. If you want to know about it, you can come talk to us. But essentially, what we wanted to do was understand when all of our groups of work were going to be done, right? And so we were forecasting our epics, the epics that our team was working on, okay? And so when I first tried to use my shiny new tool, I was super sad because what I got was a bunch of forecasts way out into the future. And now I realized from that it was because I had so-called bucket epics. Does anyone have these sort of epics that are just thematic and you throw things in? Well, how can you forecast something that's not actually intended to end, right? So you need to make smaller kinds of things. And it's funny because I'm building a tool about forecasting and I still did this. So it's not about being smart or it's not about knowing what you're doing. It's about just having to remember this stuff all the time, right? Okay, so I took a shot, and I didn't take screenshots when I did this. I remember what I did, but not the specifics, so I didn't sort of fake up a little sample there. But my first attack at breaking down those things was to make smaller epics, but somehow I made the situation where they were so highly coupled that in order to do one, you had to do two. And because for one story here, the one thing had to be done here. And so then I'm still not happy. I get a forecast, much better than the first one, but I'm not happy with it. It's not really what I wanted to see. So again, this is less about, how we forecast or the tools. This is all about how I'm working and the data that I'm generating. So in the end, the way to fix that was to take another pass. I took critique slicing class. I took another pass at, breaking down this stuff. And again, what's obvious to all of us is not always easy to do. But the best thing to do if you're trying to create a forecast of, these groups of work, projects, initiatives, whatever you want to call it, then we need to think about what's the right size of work, not the big buckets, what's independently deliverable, so not the highly coupled stuff, because then your forecast will start showing you that you're constantly delivering value, which is the goal. And not only that, but if you're working on a lot of projects at a time and you're using your data to forecast completion, it's going to look at how much work you actually get done on given days and spread it out across all of those items, right? So the more you have in progress, we all know, the longer it takes generally to get each thing done. So if I want a forecast that I'm happy with, I have to think about not letting each one of those age so much, and that means controlling how many I have in progress at once, which is my WIP. So this is more like a good thing. We took this approach because it was with our product pages on our website. And so we had heard about this thing, crawl, walk, and run. So first you build the baby version of your page, right? Just enough to put it out, the MVP, it's the crawl. Then next we go out another layer on top. I mean, basic stuff, right? The whole iterative process. But for some reason, that's not the first thing that we tried to do. But once we did that, we were much happier about the forecast that we started getting. So again, not brain science or brain surgery or rocket science or anything like that. But again, I want to challenge you to think about, yeah, all this stuff, really obvious, but are we doing it? And if we're not doing it, why? What's getting in our way? What can we do about it? Because if we think about it this way, it's not like we're trying to fix the data to make a tool work like probabilistic forecasting. It's a bit more generative than that. If we get our situation so that our data is usable for forecasting, we're probably doing a lot of other things right along the way to get us there. So it's sort of this generative cycle of if I fix this, not only will I be able to forecast, but I will have fixed things about my process that are much more aligned with the goals that we just innately have anyway. Sorry. Okay, so to sum it up, the high-level takeaway is like trying to go up as high as we can. Data tells a story. It tells you what you're capable of. Make sure you're listening to the story, right? Make it nonfiction. Make sure that the data that you get is, the correct data, because data has no agenda. You put bad stuff out in, bad stuff's going to come out. Like it has no evil intents towards you. Be an effective storyteller. If you don't know how to interpret the story that you're looking at, you're going to fall into that sort of representative trap because you might have a lot of data that's accurate, but you might not know how to use it effectively for the particular situation that you're in. And the fourth one is really about the fact that nothing is for free. You're going to have to put work in and make your process good to get good data that makes forecasts you're happy with. And so if I have to think about one thing that you can do from a forecasting standpoint and predictability standpoint is if you focus on introducing and improving flow, then you're going to see a lot of benefits throughout all these metrics and charts you're looking at that will make forecasting so much more accurate. And if that happens, you're saving so much more time and getting so much more value, and you can focus on the work that needs to be done. So that's what I have to share today. If you want to talk to me or any of my colleagues, we're downstairs. Thank you so much. No breaking news. Thank you.